Okay guys, today we're doing 3.10 quotient rule. Remember what quotient means. Quotient means fraction. Okay, so let's get started. Okay, I'm going to start us off on a problem kind of like how I did with a product rule. I'm going to give us a fraction here that can be done by either a route that we know now or with the new route quotient rule. Let's do this with the route we know right now, okay? So right now you should be able to do this. This 2x can actually belong underneath each one of these terms. So you can rewrite this. I'm going to write y equals, since I'm just rewriting it, x cubed over 2x minus 8x squared over 2x plus 4x over 2x. And that can still be rewritten because you can, simplify. So this there's 3x's up here, 1x down here. You can cancel that out to make x squared over 2. This one right here, you can cancel out one of the x's to make this minus 8x over 2. And obviously I can still simplify those coefficients. I'll do that in just a bit. And then these x's can cancel, and that can simplify to 2. Okay, so let's just simplify these two coefficients. So we got x squared over 2. I didn't change anything on the first term. Minus 8 divided by 2 is 4x, so minus 4x plus 2. Okay, now we can take the derivative of that because we have it written in terms. So let's bring down the 2. That's going to make it 2x to the 1, with the 2 still on bottom, minus 4. That's the derivative of that term. And then that term, the derivative is 0. So we're just left with this, which can simplify to 2 over 2 cancel, leaving you with x minus 4. Okay, so the derivative of this is x minus 4. And so I am going to show you the quotient rule. Then I'm going to take the derivative of this again, but with the quotient rule, and you're going to see how it comes out to be this exact same thing. Okay, so x minus 4. Okay, here is the quotient rule. It is, you're going to have some kind of fraction. You're going to call the top f and the bottom g. And the derivative, to do this, it's g, so rewrite the bottom, times the derivative of the top, minus, rewrite the top, times the derivative of the bottom, all over the bottom squared. Now there is a route to memorize this. Let me show it to you. This is not my method. It's a method a lot of people use. I learned it in college. We're going to call the top high, for it's high, it's the top of it. We're going to call the bottom ho. Okay, and you're going to see why, because it makes a little chant here. Okay, so the bottom here, G, we're going to call ho. And then we're going to take the derivative of the top, which we're calling the top high. So we're going to call this d high minus, okay, this is going to be the top. I'm just rewriting it. So high. And the derivative of the bottom, d ho, all over ho squared. Okay, that's the bottom squared. Okay, just look at this. It's ho d high, derivative of the top, ho d high minus high d ho, all over ho squared. So ho d high minus high d ho, all over ho squared. The d meaning derivative, yeah? Okay, so I'm gonna use that method whenever I'm doing this. You can also just memorize this if you want to, but I use the ho d high minus high d ho, all over ho squared. Okay, notice, it's not like product rule. If you move this and this, you flip-flop them, it's going to give you the wrong answer. So you need to make sure that you memorize it in order the way it's supposed to be done. Okay? Let's go forward and do that same problem we had. Okay, earlier, I'm trying to remember off the top of my head, I believe it was x minus 4. I believe that. So the derivative of this is x minus 4. So let's do it with our new method of quotient rule. This is my top. I'm going to call it high. This is my bottom. I'm going to call it ho. Okay. So it's ho d high, and I'll even write this on top, ho d high minus high d ho, all divided by ho squared. I'll write that right afterwards. Okay, ho, that's just rewriting it. 2x is what the bottom is. D high, the derivative of the top, it's going to be 3x squared minus 16x plus 4. That's the derivative of the top. Minus high, we're just going to rewrite this. 8x squared plus 4x. D ho, the derivative of the bottom, which is just 2, all divided by ho squared. So this thing squared, which is going to be 2x squared. Okay, let's start simplifying this. That is the derivative. Now if you notice, it's not x minus 4, but if we simplify it, it should be x minus 4. So let's simplify and see how this works out. Okay, so I'm going to have to distribute this 2x into all of these, and I'm going to have to distribute this. Now, here's what I usually do on this. See, we have to distribute this negative and this positive too. So what I usually do is I usually put a positive here and move that negative over here, and now I only have to worry about distributing one thing. Okay, that's just my method to my madness. Okay, let's do this. 2x times 3x squared, 6x cubed. Next one, minus 32x squared plus 8x. Okay, that's me distributing the 2x into all three of those. Okay, now distribute this negative 2 there, which is going to make it negative 2x cubed. Negative 2 times that is going to make it plus 16x squared. Distribute that one, minus 8x, all over. Now this 2, this squared goes to both of them, so 4x squared. Okay, let's just keep simplifying here. We got to combine like terms. So the x cubed combines with this one, the negative 2x cubed. That would make 4x cubed. Okay, now the x squareds combine. You got a negative 32 and a positive 16. That gives us minus 16x squared. Okay, now we got a plus 8x and a minus 8x. So those cancel each other out. All divided by 4x squared. Okay, let's keep simplifying. So it looks like we can factor stuff out of the top here. A lot of stuff similar. It looks like each term has a 4. Okay, and it looks like each term has an x squared. Okay, let's see, what do we got left in this term? If we took a 4x squared out, all we would have is an x. Okay, if we took a 4, we'd have a 4 left in here, but we took out the x squared, so it's just minus 4 all over 4x squared. Okay, these 4x squareds cancel, leaving us with x minus 4. So the quotient rule comes out to the same thing as the way we did it earlier with the power rule. Now, you might say, oh, well, this was a lot more work than the other one. And yeah, on this case it was, but it's not always going to be like this. If you were given this option to take the derivative of this, I would have done it the other way. But I just want you to see that you can do it the quotient rule, yeah? So let's do some where you cannot choose that you have to use quotient rule. Okay, so here we go. This one right here, you got to use quotient rule. You can't split up the stuff because there is addition on the bottom, okay? If you notice, let me go back real quick. If you notice, this was only one term. That's why you can split it in between all three terms. If there's two terms on bottom, you got to use quotient rule. So, this is my high, my ho. So, ho d high minus high d ho all over ho squared. Okay, ho is negative 3x plus 2 parentheses That's a plus. D high, the derivative of the top is going to be 8x minus high 4x squared plus 9. D ho, the derivative of the bottom is going to be negative 3 all over ho squared. Negative 3x plus 2 squared. Okay, and remember we now need to distribute that to both of those. Looks like we got to distribute this negative and that negative 3. Remember my method here, I would just multiply these two first, and that would make them a negative times a negative, makes them both positive, so I can just fix it like that. And now I just need to distribute positive 3 to both of those. See what we get. Okay, so 8 times negative 3, so we got negative 24x plus 16x. Oh, I'm sorry, that was x squared. Because it was a x times an x. And then distribute the 3 into both of those, so plus 12x squared plus 27 all over negative 3x squared, x plus 2 all being squared. Okay, now this squared doesn't go into both of them like it did on the other one because there's a plus here. So really it means this times that. It's the same thing twice. Okay, let's combine like terms. This one combines with this one, giving us negative 12x squared. Okay, this, the positive 16 combines with the positive, I'm sorry, never mind, they don't combine because that has an x, that one doesn't. Okay, so we're just going to have plus 16x plus 27 all over, and I would just leave the bottom as this being squared because sometimes it cancels out with things on top, so I don't like factoring it out. And that is your derivative. And I should have properly labeled this from the start. When I started, I should have said that's my derivative. I just had forgotten. Okay, so there's my derivative. And that cannot be simplified anymore, so I'm going to leave it like that. Okay, let's try a couple more here. Okay, I think this is my last slide, actually. Let me see if it's my last slide. Yeah, okay, this is my last slide. So, use the information to find when the slope of the tangent line is 0. Okay, remember, slope of a tangent line is the key to take the derivative. And then when it is 0, that means we're going to set the derivative equal to 0. So let's write what we're doing here. We're going to take the derivative of f, and we're going to set that thing equal to 0. Okay, that's my end goal. Okay, let's actually do that. Okay, here's f. Let's take the derivative. High, this is ho, because we have a fraction. So f prime. Okay, it's ho d high, the derivative of the top. Remember, the derivative of e to the x is just e to the x. So ho d high minus high, just rewrite it, d ho, the derivative of g is g prime, all over ho squared, the bottom squared. Okay, notice here that I didn't write out my stuff on top, but I will real quick. Ho d high minus high d ho all over ho squared. So that's how I created that bottom there. I mean that numerator and denominator. Okay, if you can factor anything out of these top terms, I would. And in this case, I can. Both of the terms have an e to the x. So I'm just going to factor out an e to the x. And what I'd be left with in this first term is g of x minus what I'd be left with in this term is g prime of x all over g of x squared. Okay, I am trying to find out, it says use the information to find when the slope of the line is 0. So I'm trying to find out when this is equal to 0. Okay, so I'm trying to find out when this is equal to 0. One thing here is it looks like I'm going to need my g of x is 2. And look at this. It looks like my function is always 2. So then let's look at what I have g of x right here, but I need a g prime. I don't know what that is. So let's see what the derivative of this would be. G prime of x. The derivative of any constant is 0, right? So since I know g of x is just always 2 and g prime of x is 0, I can plug those things in here. Let's see what happens. So I don't know anything about this e of x, so I'm going to leave it as e to the x. Okay, g of x is 2 minus g prime of x is 0 all over g of x squared, which is going to be 2 squared equals 0. Okay, well, simplifying this just gives me 2 e to the x over 2, I'm sorry, that's 2 squared. So I'm going to rewrite that as 4 equals 0. Well, that's the same as e to the x over 2 equals 0. Yeah, I just simplified the 2 and the 4. Okay, let's multiply the 2 over. Well, that's going to give me e to the x equals 2 times 0 is still 0. Okay, and then let's do the natural log so we can solve for it. Okay, natural log of e cancels each other out, leaving me with just x equals natural log of 0. Okay, well, if you think about your graph of natural log, let me graph it real quick. Crosses at 1, right? The only value we know about it is natural log of 1 equals 0. And if you notice, it never touches x equals 0. So we don't know when natural log of 0, it doesn't happen. So there is no point. So x does not exist. There exists no values where this function has a slope of 0. Because we took the derivative, we set it equal to 0, we plugged in everything we knew, and just x doesn't exist. There is no point where this graph has a slope of 0. Okay.